In this question, you're asked to find the probability that Jorge has won at least one prize. And so we look to the rest of the problem for the information we need. It says that each ticket has a probability 0.3 of winning a prize. So the probability of winning is 0.3. And Jorge is going to play this lottery for 6 days. So we have 6 occurrences. I can write n equals 6, and not really. We need the 6. I don't need to give it a variable name. So how do we calculate this? The probability that he wins at least one. Well, the tricky part with this is that we'd have to take what's the probability that he won exactly one and figure that out. And then the probability that he won exactly 2 and calculate that. And then find the probability of 3, 4, 5, and 6. And then I'd have to add all those probabilities together, and that's a lot of effort. And these problems get really big really quick, so that would take a lot of time. What's much easier is instead of saying what's the probability he won at least one, what's the opposite of that is the probability that he won nothing at all. So that's what I'm going to calculate first. So I'm going to find the probability of no wins in 6 days. And the probability is the same each day. So we know the probability of winning is 0.3. So now what we need to find is the probability of losing each day for 6 days. So do this. If the probability of winning is 0.3, the probability of losing is 0.7 because it's just the opposite and they have to add up to 1 because he's either going to win or lose. He can't be somewhere in between. So to find the probability that he has no wins, and the probability is going to be the same each day. So we take our 0.7, and it's really 0.7 times 0.7 times 0.7, and so on for the 6 days, but I'm just going to raise 0.7 to the 6th power, and that's a lot quicker. So now I calculate that, and I get 0.117649. And the problem says to round to 4 decimal places, so that's going to be just 0.1176. So the 4 tells you to keep that number the same, chop off that part, and that's my final answer.